All right, so we're going to talk about stoichiometry, and this is a very, very basic introduction and introductory notes to stoichiometry. So the first thing that you need to know is just generally what's the definition of stoichiometry. If you break down the word, geometry, you guys have heard before in like geometry class, that is Greek for measuring or measurements. So geometry would be measuring shapes. Stoichiometry, on the other hand, is measuring elements. That's all fine and dandy, but to break down the definition a little bit more, we do calculations with stoichiometry, so we are going to be using math measurements. But it is a calculation to determine the amount of product formed from a certain amount of reactant. So if you know how much stuff you're using to do a reaction, you can figure out what or how much of your product you will be forming before you even do the reaction. The same could be said for the other way around. So if you have a goal amount of product that you want to form, you could use that and say, okay, if I know I want to make 120 moles of water, how much hydrogen and how much oxygen would I need? And you could do the calculation in reverse. It's the same steps, but you would just be working backwards in that case. The roadmap for the mole is the exact same roadmap that we had at the beginning of the year. The one thing that I'm going to tell you is if you were to put grams next to mass and you put the number of, or the types of particles over here on the right hand side, it'll help you a lot when you go ahead and actually start using this roadmap. So number of particles or types of particles that we use in chemistry most often would either be atoms or molecules. So you're going to want to add those to your roadmap. The other thing that I find that helps a lot of my students is if you don't think of the mole as the mole. That's a weird word that you may or may not remember from first semester. But if you think of it just as a group, so a group of particles. So if I were to say that I have a mole of particles, just think of it as a big group. And that group has 6.022 times 10 to the 23rd particles. But the reason a lot of the students have issues with the mole is because it's such a large number that you don't really, or you have a hard time wrapping your head around. We've used subscripts and coefficients a lot in our most previous units. You guys have used subscripts as the number of each atom or the number of atoms of each element in a compound. I'm going to tell you that that is still true. There's nothing wrong with that. But the thing that is kind of cumbersome is the fact that we can't count individual atoms when we get to the lab and we're actually doing reactions. So instead of individual atoms, most of the time when we're doing stoichiometry, we think of the number of moles. So we think of subscripts as a number of moles of each element. Subscripts are used most often when you have a single compound, so you don't have a reaction. An example here, if I have NF3, before we were saying that we have 3 fluorine atoms in one molecule of fluorine. If you just scale that up so you can actually visualize it, moles, remember, is groups. So now we have 3 groups of fluorine for every 1 group of NF3. And a lot of my students tend to understand that a little bit better. Coefficients are used when we have a reaction, so we or a balanced equation. So if we have an actual equation or a reaction that's happening, something is changing, that's where we use the actual coefficients. Remember, the coefficients are the bigger numbers in the front of each of the substances, and they can mean exactly the same thing. So for every 2 moles of hydrogen, 1 mole of oxygen is used. Or you can scale it down and say I'm only going to use a half a mole of hydrogen. Then I'm going to use half as much oxygen, so that's 0.25 moles. The thing that you want to remember, and the big key thing from this slide I want you to know, is that you're going to use your subscripts and your coefficients for mole to mole ratios, and you're gonna want to make sure you have that written down on your notes, because I will refer to it when we go ahead and do some examples. So make sure that you have all of this written down on your notes, that you use subscripts or coefficients for mole to mole ratios. Okay. Like I said before, these are the same steps for unit analysis problems that we used at the beginning of the year. Nothing has changed here. Step 1, write down what you know. Make sure you include your units. This is key for this unit. You need to have your units and your label, and I'll explain what all of that means. Step 2 is figure out what the question's asking. Write down your goal, and this one goes on the right-hand side of your line. Number 3, use your conversion factors that you know. Most of the time you get those from your roadmap to cancel out top and bottom units, and then you're going to multiply the numbers on the top and divide the numbers on the bottom in order to solve your problem. Okay, so same 4 steps that we've been using. I did add 1 step to your note sheet, and that is if you have to either write an equation or you're given an equation, make sure that it is balanced before you actually use it. The last thing that I'm going to include on these introduction notes is just how many steps each of your calculations will be. This does not always work, but it is a general rule. I'd say about 80 to 85% of the time it works. But if you use the mole roadmap that I showed you up above and you figure out how many steps your problem is from that roadmap, that would be the first part of figuring out your number of steps. Then you need to see, does the label change? If the label changes, then you add 1 more step. So it's however many steps you have from your roadmap. Then if your label changes, you add 1 more step. Okay, so that's the general rule. The one thing that you do need to know for all reactions, if you are going from grams of one thing to grams of something else, it is always 100% of the time a 3-step problem. And we'll do some examples with both of these, and I'll kind of go through these examples with you along with the roadmap here in a second. So this, I'm hoping, helped you fill out your note sheet. If you missed class, I'm hoping it'll help you refresh. If you're struggling with something, if you take a look, there will be a couple more videos with some stoichiometry examples that you can actually go back